students, this is Indrani ma'am from Rasayan. In this lecture I am going to explain arrange the followings in decreasing order of reactivity towards SN2 reaction. 6 questions are given. First I will discuss some important points on SN2 reaction. Let's start. SN2 is substitution nucleophilic bimolecular. Now some important points on SN2 reaction. Now see, this is attacking nucleophile, this is leaving nucleophile. In SN2 reaction, breaking of bond between the leaving group or leaving nucleophile and the carbon atom and the making of bond between attacking nucleophile or incoming nucleophile and the carbon atom takes place simultaneously. This is transition state. So bond breaking, bond making both take place simultaneously. This is called concerted step. Attacking nucleophile attacks from the backside. So at the substrate is alkyl halide, 4 bonds are shown here, and at the transition state there is 5 bonds. 3 bonds are complete bond and 2 bonds are broken bond. So transition state, you can see it is pentavalent. It is badly crowded transition state. Now substrate is having 4 sigma bonds. It is sp3 hybridized, and here between 2 bonds bond angle is 109 degree. And this transition state in SN2 reaction is trigonal bipyramidal. These 3 groups are in a plane making bond angle 120 degree. Between these 2 bonds bond angle is 120. Between these 2 bonds bond angle is 120. Between these 2 bonds bond angle is 120. But each of these leaving nucleophile or attacking nucleophile makes angle 90 degree with any of these 3 groups. So this bond angle is 90 degree. Or this bond angle is 90 degree. Since the reaction takes place via crowded transition state, availability of space for attack on this carbon by incoming nucleophile decreases with increasing steric crowding or steric hindrance in the substrate. So the rate of the reaction decreases. Rate of this SN2 reaction depends on the structure of the substrate, stability of the transition state, solvent, on incoming nucleophile and on leaving nucleophile. Incoming nucleophile means attacking nucleophile. So in this video we will discuss some questions which are related to this and this. Remember, rate of reaction is inversely proportional to steric crowding. If in the substrate steric crowding is there, then that steric crowding will be there in transition state also. So energy of the transition state will increase and rate of the reaction will decrease. Now see, with respect to this leaving nucleophile or leaving group, this is alpha carbon, this is alpha carbon, this is alpha carbon. So if here hydrogen is there, transition state is like this. Now at alpha carbon we are increasing branching, means here 1 hydrogen is replaced by CH3, here 2 hydrogens are replaced by CH3, here 3 hydrogens are replaced by CH3. So here steric crowding in the transition state is less, but here since this and this bond angles are 90 degrees, so steric crowding increases. Here also 2 methyl groups are there, so with this methyl and with this nucleophile, here steric crowding is there. Here with this methyl and this nucleophile, this methyl, this nucleophile, leaving nucleophile, with this methyl and with this methyl and this, steric crowding is there. So steric crowding is increasing in this direction. Here more crowding is there because 3 methyl groups are there. So in this direction, in the transition state, steric hindrance or steric crowding increases. So what will happen? Energy of the transition state will also increase. Therefore, rate of the reaction decreases. Because if in the substrate more crowding is there, it is difficult for the attacking nucleophile to approach there and to attack. Now see, this is transition state of SN2 reaction where substrate is tertiary butyl halide and here substrate is neopentyl halide. So what is the difference between these two transition state? Here with respect to this leaving group, this is alpha carbon, here 3 methyl groups are there. With respect to this leaving group, this is alpha carbon, this is beta carbon. Here branching is there at beta carbon. So it is observed that there is steric interaction between all these 3 methyl groups with this nucleophile and this leaving nucleophile. Here this big group is present. So there is steric interaction between this big group and nucleophile and big group and this leaving nucleophile. And this steric crowding is more than this. Here steric crowding is more here. So this transition state is having higher energy. Therefore, for this rate of the reaction is slower. Almost there is no reaction. Now we will solve some problems. Remember, as the branching at alpha and beta carbon atom increases, the SN2 reaction rate decreases. With respect to this halogen, this carbon is alpha carbon, this carbon is alpha, this is alpha carbon. So in the alkyl halide, from left to right, branching at alpha carbon increases. So SN2 reaction rate decreases because transition state will become more crowded. So it will become less stable. So decreasing order is this one. With respect to this halogen, this carbon is alpha, this carbon is beta. So this is beta carbon, this is beta, this is beta. So from left to right, branching at beta carbon increases. So SN2 reaction rate decreases. So order will be like this. So we can say reactivity for SN2 reaction for the substrate is inversely proportional to steric crowding or steric hindrance of the substrate. With increasing steric crowding or steric hindrance at alpha or beta carbon atom, reactivity decreases. So in problem number 1, we have seen that for SN2 reaction, reactivity rate of 1 degree halide is most, then 2 degree halide, then 3 degree halide. Remember this thing. Now for the next problem, see, with this carbon 2 carbons are attached, so this is 2 degree halide. This is 1 degree because with this carbon only 1 carbon is attached. So this is 1 degree halide. This is also 1 degree halide. So we know 1 degree halides are more reactive than 2 degree halide for this reaction. So this is least reactive here. Now see, this is transition state for SN2 reaction. Here delta minus charges are there. This is leaving nucleophile, this is attacking nucleophile. So if any electron withdrawing group is present with this carbon, it will abstract electron density from these two and negative charge density will decrease and the species will become more stable. So reactivity of the substrate will increase. Now see, Cn is electron withdrawing. Since Cn is electron withdrawing, so it will stabilize the transition state for SN2 reaction more than transition state whatever we will get from this substrate. So between these two substrates, since it is electron withdrawing by minus I effect, so it is the most reactive species here. Remember, reactivity of the substrate for SN2 is directly proportional to presence of electron withdrawing group at this carbon due to minus I effect. So this is most reactive, 2 is most reactive, then is 3 and this is secondary halide, so this is least reactive here. In this problem, 4 compounds are there, these are benzylic bromide. See, all these are 1 degree benzylic halide. Now see, nitro is electron withdrawing by minus I and minus R effect. NH2 is electron withdrawing by minus I but it is having plus R effect. Here no such substituent is there at para position and now here in this compound methyl group is there which is having plus I effect and positive hyperconjugative effect. So this is electron withdrawing group, it is present at this carbon atom. So it will stabilize the transition state most. Therefore, this is the most reactive species. Next is this one, because here electron donating by Placer effect group is present, and here also methyl is electron donating by hyperconjugative effect. And always remember, resonance effect is more than hyperconjugative effect. So inductive effect we are not considering at para position here, but it is having Placer effect and it is having hyperconjugative effect, and Placer effect is more important than hyperconjugative effect. So it is more electron donating. Therefore, this is least reactive here. So next is 4. After that, least reactive is 2. And since no such electron donating group is present, so it is more reactive than 4 and 2. This is the order. Next is this problem. This is vinyl chloride. This is propyl chloride or chloropropane, and this one is allyl chloride. Allyl chloride. Now see, this carbon is 1 degree, this carbon is also 1 degree. But here with this group is attached, this carbon is sp2 hybridized. And with this carbon, one carbon is attached which is sp3 hybridized. And this halogen is attached directly with sp2 hybridized carbon. This is vinyl chloride. This is acetylenic chloride, this is aryl chloride. Remember, all these halides are very unreactive towards SN2 reaction. Now see, this carbon is sp2 hybridized, this carbon is sp2 hybridized, this carbon is sp hybridized. So these carbons are more electronegative. Then it is not possible to break this bond and Cl will leave with this bonding electron. It is not possible. That's why these are unreactive for SN2. And in this compound, this is primary carbon, this is primary carbon, but with this carbon electron withdrawing group is present. Since this carbon is sp2 hybridized, so it is having minus I effect. So electron withdrawing group is present with this carbon, so this is most reactive, then this 1 degree, and then this is unreactive. So this is the order. Here this is 2 degree carbon, 2 degree halide, this is 1 degree, this is 1 degree, this is 1 degree. So 1 degree halides are more reactive than 2 degree halide for SN2 reaction. So this is least reactive. But what is the order of 2, 3 and 4? Now see, with respect to this halogen, this carbon is, with respect to this carbon, this is beta. So at beta position branching is there, here at gamma position branching is there. Here no branching. So which one is most reactive? Here no branching is there, 1 degree. So this is most reactive. Then here see, at gamma, far from this position branching is there. So the activity is in this order. Beta branching. If alpha and beta branching is there, then reactivity decreases. So it is coming next. So this is more reactive than this, because here at beta position, nearer to this center, branching is there, but it is far from this center. And least reactive is this one, because it is 2 degree. In this video till this, if you like, please subscribe. Thank you for watching.